Today we are going to be solving linear inequalities, not equations, linear inequalities. Inequalities are, it's like an equation, but it involves less than, greater than, less than or equal to, greater than or equal to. So I feel like we should know this, but just in case you don't, that would be these symbols. Less than, greater than. Less than or equal to, greater than or equal to. The less than symbols look like the squished L's. Okay? I feel like I don't need to say that, but there's usually at least one person in one of my classes who's like, oh, the squished L's. Okay, I get it now. So I say it. All right, these steps right here, these options listed under the bullets are really, really great. I've actually never seen it written out quite like this, and this makes a lot of sense. So these are things that you can do in the process of solving inequalities. You can add or subtract the same number to both sides. You can multiply or divide the same positive number on both sides. Or you can multiply or divide the same negative number on both sides and reverse the inequality. If you multiply or divide an inequality by a negative number, the sign has to switch. So let's look at our first example. 2/3 x plus 3/4 is greater than 1/6. Do you want to solve it using fractions, or do you want to make the fractions go away? Make them go away. So look at the denominators, 3, 4, and 6. 12. We're going to multiply everything by 12. So 12 times 2/3, and you can use your calculator's fraction buttons to help you. That is 8x. 12 times 3/4 is 9, and 12 times 1/6 is 2. If you are unaware of how to use your fraction buttons to make your calculator do all of that work for you, please let me know, and I would be happy to show you. All right, now, to solve this, we're going to treat it just like an equation. We just have to keep in mind these last two bullet points. If you multiply, bless you, or divide by a negative number, you have to reverse the sign. So we're going to subtract 9 on both sides. Subtracting 9 does not cause us to have to change the sign. So 8x is greater than -7. We then divide by positive 8. We're dividing by a positive number, so the sign does not change. -7/8. X has to be larger than -7/8. The next example, 3x minus 6 over 4 is greater than 0.6. Because this problem has a decimal in it, you can write your answer as a decimal, especially if it's a terminating decimal and not something you have to round. Okay? What do you think we should do first in number 2? Any ideas?
I was thinking make the 0.6 into a fraction and then find.
You could.
Or like multiply by 20.
Good. I think that might be, in this case, I think using that decimal might actually be easier. The big thing is we've got divided by 4. How can we undo divided by 4? Multiply by 4. So I would start by multiplying by 4, and that will just make this look a little bit nicer. 3x minus 6 is greater than
2.4.
Okay. All right. Then we would add 6 on both sides, which would be 8.4. And then divide both sides by 3. And this is the decimal 2.8. 2.8 is a nice terminating decimal. It's not multiple numbers after the decimal point, so we can leave it as 2.8. If you want to change it to a fraction, that is also fine. It would be the fraction 14/5. So x is greater than 14/5. But if your problem starts out with decimals, it's fine to write your answers with decimals. The important thing with inequalities, do you notice our answers are x is greater than something or x is less than something? You want your x to be on the left, then the inequality symbol, then the number. So in the process of solving, say we ended up with 2.8 is less than x. You would need to switch it around, but when you switch it around, that would also switch that sign around. So make sure that the sign is eating the same thing no matter how you write your answer. If the sign is supposed to be eating the x, make sure the sign is eating the x. All right, compound inequalities. Compound inequalities are inequalities that are connected by the word and or by the word or. An and inequality is basically where the solutions overlap. 0 is less than or equal to x, and x is less than 4. That means x can be larger than or equal to 0, but at the same time smaller than 4. This inequality can be written as a three-part inequality. 0 is less than or equal to x is less than 4. The important thing when you write a three-part inequality is that the symbols have to be less than symbols, and it has to be smaller number, a less than symbol, a less than symbol, and then the larger number. It has to go from smallest to largest. This is written out words how you could say this inequality right here. Graph the following compound inequality. I mainly want you to see what an and inequality looks like, because we will later be graphing an or inequality, and I want you to notice the difference. In here we have the numbers -2 and 0. I am not picky about how precise your number line is. If it says -3 is less than y is less than or equal to 0, I need to see -2 and 0. Did I say -3? I don't know. I need to see -2 and 0. -2, it's a plain old less than symbol. That means an open circle. Do you remember open circle, closed circle? Okay. Less than or equal to at the 0 means a closed circle. And then y is everything in between that. Y has to be smaller than the 0 and larger than the -2. So you shade everything in between. An and inequality is two numbers, you shade in between them. To solve an and inequality, theoretically we could split these up into two separate inequalities and solve them separately, but the shortcut, strategically lazy, is to solve it all in one step. So this one is going to be, I'm just going to rewrite it so it's easier for us to see. -2 is less than 3x plus 1 is less than or equal to 4. The key here is that we have three pieces in this inequality. We've got the left, the middle, and the right. In the middle, we want to get x by itself. Whatever we do in the middle to get x by itself, we have to also do to both the right side and the left side. So you're going to be solving a three-part inequality. First thing I would do to get x by itself is subtract 1, which means we subtract 1 in the middle, and on the left, and on the right. What should we do next? Divide by 3, and if we divide by 3 in the middle, we divide by 3 on the left and on the right. We divided by +3, so the signs don't change, and our answer is -1 is less than x is less than or equal to 1. We're supposed to graph it. We can skip that. Your assignment doesn't have any graphing on it. The next one is -7 is less than or equal to 3 minus x is less than 5. What should we do? Subtract 3. Now this is a very common mistake. That's not a mistake. Do you see the negative in front of the x? That means it's a -x. Do not add 3 because this is already a +3. We need to subtract 3 on all three sides. That gives us negative 10 is less than or equal to negative x is less than 2. What does that negative x in the middle mean? It's a negative 1x, so to get rid of it, we divide everything by negative 1. Now when you divide by a negative, it switches the signs. Okay, you do not want to leave your answer like this. The inequality symbols are going the wrong direction. The bigger number is on the left, and that's just not good. So up here, I'm going to write my final answer. Negative 2 is the smaller number. 10 is the bigger number. X has to be in between them. We're basically just rewriting it from right to left up here. But if you need to, between the negative 2 and the x, the sign is eating the x. Make sure the sign is still eating the x. Between the x and the 10, the sign is eating the 10. So check to make sure that your signs are still eating the same things when you're done. Or inequalities are slightly different from and inequalities. Or inequalities means you have two separate inequalities connected with the word or. It does not mean pick one to solve. You have to solve both of them. I have had students do that on a test. They see an or inequality, so they pick the one that looks easier and just solve one of them. It's not how it works. You have to do both of them. So our first one, x minus 4 is less than or equal to 3. We would add 4 on both sides to get x is less than or equal to 7. The other one, we would divide both sides by 2 to get x is greater than 9. Put the word or between your answer, and you've got your solution. We are going to graph one of these. 7, 9. Closed circle at 7, open circle at 9. X is less than 7, so we need to shade the numbers smaller than 7. And x is greater than 9, so we need to shade the numbers larger than 9. Do you see how and inequalities and or inequalities look different on their graph? And inequalities you shade between the numbers, or inequalities you shade outside of them. Give number 7 a try. Just keep in mind there's negatives in front of your x's, so there might be some sign switching happening. Okay, I solved this one out. We start by subtracting 5. Then we have to divide by negative 2. Because we are dividing by a negative, the inequality sign has to switch. The same thing happens on the other one. Because we are dividing by negative 3, the inequality sign has to switch. To write your final answer, put the word or in between your two solutions and box them together. Some teachers are super picky. They want the less than symbol on the left and the greater than symbol on the right. It doesn't really matter. I'm not going to be picky like that. This one does have kind of an interesting graph. Notice it's plain greater than and plain less than. That means an open circle at negative 4. X has to be larger than negative 4. So we would shade to the right. X also has to be smaller than negative 4. So we'd shade to the left. So basically, what is the only number that x can't be? Negative 4. X can be anything in the world except for negative 4.